Hello and welcome back to the Scotti-BYTE channel, and this is Scott. So today I want to talk about Linux device drivers. And in order to do that, I'm going to draw some parallels back to the Windows operating system. So Microsoft bundles a lot of device drivers along with the Windows media. And when you plug in a new device into Windows, you normally get an installing driver pop-up. And many times you end up searching the internet for an appropriate driver to support a newly connected hardware device in the case of Windows. So in Windows, the device driver must also be digitally signed, and this requires that the manufacturer has paid a fee to Microsoft. Windows may not support very old devices that do not have newer Windows device drivers, and so some hardware at this point in time has become obsolete to Windows. So in Linux, the vast number of drivers are included out of the box, and you don't have to hunt them down as you do with Windows. And I know it's kind of funny to say Linux out of the box because technically there isn't a box. So what is the Linux device driver experience like? Well, in Linux, the drivers are open source and they're integrated into the kernel, or they're a part of other software that you are installing. The exceptions to this are proprietary drivers added to Linux, and these are most often for video cards and for the common Unix printing system, otherwise known as CUPS, which are normally the device drivers for printers, but they're really trivial and there's really not much to them. So it's extremely rare for a Linux system to not have a driver for a particular device. A Linux system automatically detects your hardware and it uses the appropriate drivers. And that's why a lot of Linux users are led to believe, oh, Linux doesn't really need drivers. So in Linux, your hardware basically should just work as is. And sometimes you may have to install a proprietary driver. And as an example, in Ubuntu, they have this area called the additional drivers utility where you can manage those additional drivers. But it's really rare that you do that. As a matter of fact, I think the only time that I've ever done that in Ubuntu is to load a proprietary driver for a video card, like an NVIDIA video card, not wanting maybe to use the out-of-box Xorg experience. So a lot of people think Linux is confusing. Well, Linux may be confusing to people because there is a single file system called root, and it's depicted with a / as opposed to the drive letters you have in Windows. And what I mean by a single file system is that in Linux, if you add another physical hard drive, what you end up doing is creating a folder somewhere on your file system, and then you mount the new hard drive to that folder. So effectively, you can navigate anywhere in the file system, not necessarily know that you're on another drive, and you'll be actually accessing that additional drive. And the only way you can see that you're on another drive is by going through the mount points. And that's the user experience that they attempt to create. And so that's a little bit better than having to deal with the separate drive letter business as in Windows. So Linux desktops have a GUI and Linux servers normally do not. And as a matter of fact, Windows servers normally have a GUI as well. So in Linux, everything is a file, and even devices are rendered as files. And if you doubt that, there's a /dev directory, and inside that /dev directory, you'll see the names of the various devices that you may have in terms of disk drives. And the same is true of keyboards or mice or anything else. So basically, Linux doesn't really have devices per se. It's really files-driven system. So Windows installs and configures to the hardware. That is, when you do an installation of a Windows operating system, it detects and configures and installs for that particular hardware. Linux, on the other hand, installs to the hard drive and configures at boot time. And that's why you can generally pick up a hard drive on a Linux system and move it to another Linux system and still have it boot. In the case of Windows, because it's installed to particular hardware, if you try to do that, the normal response is a blue screen of death because it doesn't understand the configuration of the new hardware you've placed it on. So one of the complaints many times is that Linux has too many choices and Windows seems simpler. So let's go look at devices in Linux and see how we can examine a running Linux system. lscpu is a command that gathers information about your CPU processor in your computer. And so lscpu space -- help will give you the information about all the command qualifiers that you have with this particular program. I usually like to just type in lscpu by itself, but I'm going to pipe this to more in order to be able to see things page by page because it does output quite a bit of information. So the first thing we have here is our architecture. I'm running an x86-64 machine. In this particular case, this desktop is an Intel. And then we have which CPU operational modes. It's both 32-bit and 64-bit, and the address spaces, as well as how many CPUs you have. In this particular case, this unit has 6 CPUs, but it has 2 cores per CPU, so it lists out really vCPUs or virtual CPUs, so that's why I get the number 12. And going down here, it has the vendor ID, the model name, which is an i7-8700 operating at 3.2 gigahertz per core or per thread. And then it says how many threads there are per core and how many cores per socket. And it goes on and on. On the next page, as I move down here, you can see that it lists out a number of other things about settings on the CPU and options. And so all in all, it's a pretty great command to take a look at information about your CPU. lshw is a command that can show you information about your installed hardware on your computer. And although the help is fairly abbreviated, you'll discover that the command itself can be pretty lengthy. If I just type in lshw and then I go ahead and pipe it to more, since there's so much output, you can see that it says what your description is. It says computer, and then it gives all kinds of information here. Tells you about your motherboard, tells you about your CPU again, so somewhat redundant from the last command. Talks about the host bridge on the motherboard. If we hit the space bar, it goes to the next page. Talks about the PCI bus. It goes into your memory, and it goes into your various interrupts from your peripheral boards that are either add-in boards or directly on the computer. In this case, down here they're detailing the NVIDIA video card that I have in this machine. They go in and talk about the display. They go in and talk about the this thing has an onboard display. It's seeing that onboard display in addition to the add-in NVIDIA card I've got here. and it goes on and on. You see information about the USB hubs, the SATA controller, and so on. LSDev calls out all the information about your devices or peripherals you have on the system. And again, I'm going to pipe it to more because it's got quite a bit of data. I hit enter. First thing you get up here is you get an indication of various peripherals. Up here, this doesn't seem to mean a whole lot, but as you go down, you can see the different device connections. Here we have our Ethernet controller ENP4S0. It's calling out the interrupt request vectors for that. You're seeing the keyboard, the video card, the NVMe drive that's in this particular machine. Hit a space bar to go to the next screen. And again, more information about that. And you can see that it calls out PCI bus and that sort of thing. I haven't used this particular command quite as often because I don't generally need the information in it, but it's something good to know, and that's what LSDev does. The lspci command is valuable to display information about your PCI bus and all the devices connected to the PCI subsystem. And the lspci command is a part of the PCI utils package, so you may have to do an install of the PCI utils package if you find that you do not have the lspci command. The lsusb command displays information about the USB buses and the connected peripherals. So here you can see I have a Logitech webcam here, and down here I have a Yubico USB key installed, and I also have a Microsoft Trackball Explorer installed. So you can always list all of your USB devices. It'll tell you which USB bus it's on, and it will tell you the device number and also the ID, which can be valuable in configuring certain programs. The lsblock command displays information about block-based devices like disk drives and is a part of the util-linux package. And so here you can see that it gives you the name of the device. I've got a lot of loop devices on the system because of some things that I have installed. It provides you information on the size and the mount points and that sort of thing. So if we go to the bottom of this, you can see all of my peripherals. So for example, SDA means the first disk device on the system. SDA1 means partition number 1 on that particular drive. SDB is another drive on the system. It would be the second drive, and it doesn't have any partitions on it at the moment. SDC would be the third device on the system, and it would be SDC1 is the one partition I have on it. So if you had more partitions, it would be SDC2 and SDC3. So the fourth disk I have on the system is SDD, and it has one partition, which is SDD1. And that's the path you're going to see on most of your SATA or SCSI type drives connected to a system. In the case of an NVMe drive, they look a little bit different. It says NVMe 0N1, which is the first NVMe device, and then I would have NVMe 0N2 if I had a second NVMe device, and then the first partition is NVMe 0N1 for the first drive, P1 for the first partition, and then P2 for the second partition. One nice thing about LSBLK is we can see, for example, that device SDD1 is mounted at /MNT mondo-iSCSI. So if you were to do an ls of /dev/SDD1, you would see it would simply say /dev/SDD1 saying, yes, that device actually exists. But if we want to see the data where it's mounted, I would copy this and I would say ls on /MNT/mondo-iSCSI, and there you can see the contents of the files over on that particular drive. So again, mount points mount at some location on the system, and where this one is mounted is in a place called /MNT/mondo-iSCSI, and mondo-iSCSI is simply a folder, and the mount command mounts this physical device you can see here /dev/SDD1 to the location in the file system inside of the MNT folder and then inside of the mondo-iSCSI folder. And that's how Linux ends up referring to additional drives. The lsscsi command lists information about SCSI devices as well as SATA devices. And it's interesting, but whenever you see a device name with /dev/SDA, it really, back in the old days, used to be a SCSI device most of the time, but nowadays it can be a serial ATA device, and that would make it a listable through lsscsi. So everything is kind of a special case of SCSI, even though it's not. So a real good example here is device /dev/SDA, happens to be a Seagate spinning drive here. The next one, SDB, happens to be a card reader that will read SD cards or micro SD cards on my system. And then the next two devices are actually iSCSI storage that are mounted from my QNAP NAS, and they show up as /dev/SDC and /dev/SDD. And then finally, I have my NVMe drive, and that is a Samsung SSD 980 Pro 2 terabyte, and that shows up as /dev/NVMe0N1. And the reason it shows up as 0N1 is because we only have one NVMe device on this particular desktop system. The command lsmod lists the kernel drivers that are, or the kernel modules that are loaded into memory for your current configuration of your running system. And I'm piping this to more because there's quite a few of these out here, and that was dependent upon when this system booted, what it saw the requirements to be. And so you can see that there's quite a few out here. In fact, there's about 4 pages of them. There's the first page, there's the second page, there's the third page, and there's the fourth page, and there's even more. Okay, I was wrong. There's even more. Well, so basically, lsmod is a really valuable command to display the list of your kernel modules that are currently loaded into memory. This is one of the primary reasons why with Linux you don't have to go off and find additional device drivers, because at boot time it pretty much determines what is needed for the hardware that it sees, and that's what it configures. In conclusion, understanding your device configuration in Linux is helpful for your self-hosting environment as well as your entire home lab. The set of ls commands covered in this tutorial help you understand the underlying hardware of a particular system better. And Linux can often serve as an excellent diagnostic tool to examine your hardware, and that includes even examining a Windows system. You can have a Linux system that is bootable on a USB stick. You can boot it up and use some of the tools we discussed in this tutorial. So Linux provides the transparency you need in order to configure your hardware and leverage the features that you need for your applications. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.